Hello, guys. I can see people joining. We have around 11 people as of now. Okay. So, guys, I'm Karan. I help out Mahesh with the course and lightning session. It's great to see you all over here. And since everybody is joining, let me start with Mahesh's intro. Mahesh is a Gen AI PM lead at Google, as you all know, and he has over 20 years of experience in AI/ML product management. He has formerly worked at AWS, Meta, Microsoft, and what makes him unique is he specializes in deploying large language models, based services, and enhancing AI infrastructure at companies. And some of the previous work you must have heard about. Uh, it's like he has worked with Google Gemini, Meta Llama, AWS Bedrock, and now Mahesh is on a mission to educate the next generation of AI ML product managers. So here we are. Also, like if anyone has any questions during the session, please drop them in the chat or ask them live at the end during Q&A session by raising your hands, of course. And okay, Mahesh, I think we should take it. Let's welcome Mahesh.
Hello, everyone. Hi, I'm the guy who Karan talked more about. First of all, thank you for joining. I know some people, at least on the West Coast, it's early morning. It's a quick session, so we'll just get started. As people will continue to join, we'll admit them. But today we're gonna talk about a very interesting topic, which is very close to my heart because that's where I started my journey. Although Karan introduced me as the large language model expert, actually my journey started with small language models. So I built the first product I did actually, which consumers can touch and feel, was this a small, this, if you can see this small AI camera. Or the beautiful thing about this camera was that it can run AI on the edge. So your video stream need not to go to internet and you can just send insights. So that's what I built first. That was my first project in 2018. And since then we came a long way. So that was this camera. And then we build a custom vision service, which is live today also. If you go to customvision.ai, which is a link here, then what you can see is you can actually upload few images and create a model just by creating a just by putting few examples, and that's the service. And you can upload like few images, and after that you can label them like cat, dog, or whatever you want. And after in 2-3 minutes, there will be a model that is customized to your needs. And then if you make it compact, you can actually deploy it on any edge device, including my AI camera, which I showed you earlier. So this is the few projects I have done in the area. Uh, I didn't stop there. I said, okay, this is about my camera. It's a developer kit, but most of you don't have that developer kit. So how can we actually take this camera or any camera in the world and take their stream and then deploy, train models with no code, and then in a click of a button, deploy to any camera, which is can be an any camera that can send an RTSP stream, which is a $30 camera. So by the way, all these slides and links are there. So Karan will paste the slide and you get all the links also. So there are labs and sessions. So here is a lab where you can take any $30 camera. There is a link to buy that camera also. And then in few steps, you can actually build an end-to-end AI project with not LLMs, but Vision AI. So today, so that was a quick introduction of me and who I am and what I have done before. But the most interesting part is what I'm doing now, which is I'm working on large language models for last 3 or 4 years. And I wanted to bring you on a journey so that we all can iterate and learn together as a team. So agenda for today is understand why LLMs are so good and what they do, then challenges in getting LLM to production, then why there's a push towards this small language models and what I believe where we are going with them. And then we'll also discuss few techniques. So we'll dive a little bit technically, not too much. There are links to go more technical, but I will try to take you as much as you need as a product manager. But if you want to do hands-on, I have put some code also if you want to play with that. And then what we will do is we'll do a very small lab, which I will leave you with, which you can actually add to your portfolio or your project, where you can take a small language model like Gamma and actually run it on your PC and hopefully build something or show something, and then see the challenges of these models firsthand, and also have something that you can iterate on. So without further ado, let's get started. I am excited. If you have any questions, I will leave like end of 15 minutes for questions. The whole idea, I'm gonna throw a lot of things at you, and the idea of Q&A is to actually digest them well. I love teaching by questions, so hopefully you will have good questions. And please continue to paste your question in chat, and Karan will be able to help us to get to them. So give me 15 minutes. Just sit back, relax, watch like a movie, and then we will get to questions, and we will double click on these ideas or more ideas that comes by your questions. Sounds like a plan, team? I think all of you said yes. So let's get started. So, uh, so let's understand just the basics, right? What is the difference between a large language model or a small language model? Uh, if you look at language models or any machine learning model, it comes down to very basic things, like a simple equation called y is equal to wx plus b, where x is the input you provide. So it can be a text input or an image input, and y is the output you get. And the job of machine learning is to train the right value of these two parameters, which are weights and biases. So these are the weights that a model has, and these are the biases. You start with some random values, and then you show them examples, or you say this is the right value, and you adjust the value of these weights and biases. So that's the simple idea. This is the simplest equation of a machine learning model. And these weights and biases are nothing but a set of metrics called weights. And you will have numbers here 0.23, 0.44, 0.456, 56. And the idea is that if you take an example, will Mahesh teach today a class? The answer is binary yes or no. So 0 means yes, no, and 1 means yes. Then if my input is what time Mahesh woke up, and that depends whether he will take the class or not. If he wakes up at after 8 p.m., 8 a.m. he can't. So that's one input I can take. But there are other things also. That is Mahesh feeling well and all that. That maybe we want to train. So these values we will take randomly and then take previous examples of how many times I have showed up in 8 a.m. classes. And those examples, if we show, based on that, we can train a right value and then predict whether today I will have the class or not. And hopefully you will predict 1. That means you got the right values of W and B in this matrix. So that's the simplest way to think about these models. And now comes the exciting part, which is we say large language models and all. Large language models has a lot of parameters. So the idea is if you have long number of parameters, these weights and biases, if you have a huge matrix, how huge? How huge? So GPT 3.5, 3, before even ChatGPT was launched, have 175 billion parameters. What that meant was that it had the weights and biases value, two metrics, weights and biases, and their value, total number of these, if this is 1, they had 175 billion of these numbers here. And because these numbers decide what you can learn, a large model continues to learn a lot of things, while a small model couldn't learn a lot of things. So that is the idea or the main difference between an SLM, small language model, or large language model. Large language model has parameters more than a million, at least. And you can think of small language model, you can say billion these days. And then more than a billion, 1 billion, and you can say 1 to 3 billion is SLMs. I know this doesn't sound small, but we can discuss more in the class or during the questions what actually is SLM and why we are saying these are SLMs, even if they have 3 billion parameter models. So that's the idea. On this side, we have gone to trillion parameter scale. The latest model that is coming out are trillion parameters. Here we are going and reducing the size. Good results I have seen is 1 billion parameters. So billion to trillion. That's the race we are on. So that's the basics. The basics are every machine learning model has an equation has parameters, and the number of parameters decide whether you are dealing with a small language model or a large language model. Got it? I believe everybody said yes. I will just keep moving because generally I like more interactions, but this is a quick session. So I will just assume a lot of things that all of you are having fun. By the way, I love people if they can turn their camera on. So I know that I'm not putting you to sleep, but if you can't, that's okay too. I know there are a lot of people. So just make sure uh, if you can, then I would love to just see, especially if you're asking a question. Thanks. So what happened is when we trained these models, once we were training it for some basic things like can they do natural language processing? Can they understand the language? But then we saw emerging techniques or emerging qualities of these models. So a lot of things came along when we threw more and more parameters. More weights meant it can learn more things. They learn common sense reasoning. They learn logical inferences, logical inferencing. So all these emergent techniques, or as the number of parameter increased, these behaviors increased, and that made it possible for us to build a generic tool like ChatGPT, which, if you tried, you felt like some magic. You felt like somebody like human came along and have all the world knowledge and actually answer questions rather than throwing search results. So that's the beautiful part about large language models, that if you continue to increase the number of parameters and learn, they show new and new emergent behaviors. What can they learn? Nobody knows actually. We are continuing to increase the sizes and the techniques to train these models, and we are learning more and more emergent behaviors. Uh, and right now, we don't know what the limits are. We just have limits on how much compute we can throw at them. So that's the landscape of the situation, and that's the world we live in today. So that's one trend. More and more parameters people are throwing at these models, making them super capable by learning a lot of things. Second trend that is going on is that hey, there is so much cost to these, and people are looking to create differentiation in their products. And how you bring differentiation in your products is, uh, hey, you make them private, and you should control what is goes in this model, because if everything is getting controlled by these four providers of large language models, then what differentiation you can bring? How can you train these models, or how can you get the copy of weights and biases, which is not possible for a trillion parameter model scale? Nobody except Llama or Facebook, which shared a 405 billion parameter publicly. Nobody is sharing their trillion parameters model with you. So how can you actually take these weights and biases, or how can you take a model and actually own it or build on top of it? Is the another way enterprises are moving towards. Mainly three reasons it is why they are going towards SLMs or small language models. One is cost. Cost of just hosting or using the large language models is too high. Too high means it costs you almost a scale of a 100K or so to run a 405 billion model at scale for an app in your lab. So that's the kind of cost you're going through. So you want to avoid that cost. That's why you want a small model, so that it can actually work on your PC, or a small chip which costs you $500 per month rather than $5,000 or $50,000 per month. So that's the first reason. Second reason is privacy. People don't want to send all their information, sensitive things like their contracts, things like what what you have in your company, your modes, over internet. And especially government agencies or banks are bounded by regulations to not send this data outside. So all these will need small language models. As more and more use cases emerge, you will have more and more need of SLMs. And the third need, or the third problem that you have with large language model is, because to answer a question, they need to run through these trillion parameters. This takes a lot of latency. So generally an answer comes back to you not in seconds, but it might take minutes if you give them a large enough context and ask a question. And most of the application can't wait for a minute. So how can you actually reduce the size so that you can get answers within seconds? That's the other idea here. So these are the challenges: latency, cost, and privacy, that are pushing the ecosystem to innovate more and offer small language model, especially if you're trying to build products that actually have ROI beyond research. If you're trying to bring these innovations of large language models to enterprise or build apps, then you have to solve these three problems. And that's, I believe, is the push towards small language models. Now, the next question is, okay, we the small language models were already there before large language model ever arrived. I worked on them in 2016, 2017, and NLP has not evolved. We had transformers since 2017 or 18. What is new here? And what is the advantage for people working in small language models? There are three actually. The learnings of a large model can actually train now a small language model much faster, quicker, and cheaper. That means it is the most cheapest way to create SLMs is now, because you have a large language model, and we'll discuss some of these techniques, which can be actually used to create small models with minimum cost. Second is, the biggest challenge of building these models is creating data. But now you can use large language models to generate synthetic data to train these small language models. And then third is, there are techniques like inference optimization, like quantization and pruning, which I will touch upon later, which allows you to just take them and make them faster and smaller for using at the application. While at training, you can have a large model, but when you are trying to use it in your app, you can actually optimize it with simple techniques like quantization. Okay, so I know I'm throwing a lot of technical stuff, but we'll open those boxes as well as we go next. So I think what you got is what a model is, why we need SLMs, and what is the advantage now to work on SLMs or actually build or learn SLMs. If you got that, I think you're following along. If you joined late, I just did it for Yating because she joined late. So I have to summarize for her. She turns on her camera. So three techniques which are very popular. If you're working in this space or learning this space, I will highly recommend you to read them. I teach a course also on Maven, so we talk about these in detail in different sessions. But today I'm going to touch upon these three and what they are, so that you at least have an idea. And then there is a details tab, so you can use that tab to actually learn how this is done. Okay, so we are trying to say, how can you reduce the size of a model? So let's say now you have a model which is W plus Y plus X, and if you open the box of a model, what you will find is billions of weights here, right? So this will be billions of weights, and another matrix called Bayes matrix, which will have another set of weights, right? So that's what you will find if you open, or if you can actually peek into a model. If anybody says model, it's nothing but two metrics, a huge matrix of weights and a huge matrix of Biases, right? Simply put, that's what a model will look like. So how can you reduce the size of this model? So that's the techniques we are discussing. So number one way you can do is quantize. And quantization is nothing, but you are saying, hey, in what precision should I store these models? Right now, this single digit is taking 32 bits because you are storing them as float. And if you reduce from float 32 bits to int4 quantize, then you are using only 4 bits. So you have reduced the size by 8x. So that's the first technique. In this technique, what you do is you just, instead of using float, you are using 4 int4 to store them. That means you are letting go a lot of precisions because you are using 4 bits to store. That means you can't store values after dot or points. But overall, you might lose some accuracy here, but there are techniques where you can train them and do a good job. And using those techniques, this quantized model, although 8 times smaller, actually perform, let's say, at 92% accuracy, and this will be 96. So you're losing just 4% accuracy, but you are reducing the size by 8x, which reduces the size of running or dollars by at least 100x. So that's the gain for product managers. So you can reduce the cost of running this by 100x by just reducing the size of the model by quantizing it. So that's our first technique. The second technique that you see in the slide deck is called pruning. So what you can do is you can also say, hey, let's just prune this model. In this technique, what they do is they say, hey, at the time of training, they come and they say, hey, if the weights are below, let's say 0.3, I don't know how much value they are adding to this equation. Let's just all set to 0 or completely remove them. So you're basically reducing the number of parameters by setting a threshold, let's say 0.3, if the range is 0 to 1, and you are saying, hey, just remove these. So at least you reduce the size by 30%. And generally in a model, it is less than 50%. So you have reduced the size by half. And your cost should go at least 4x better, right? So that's the second technique called pruning. And the last one, which is the most exciting one, which is almost used in all the models that you have seen, the small models like Llama 3 or Gamma, or this is a small model publicly released by Google. This is Meta or Pi 3 by Microsoft. And this technique is very simple. What they are saying is, hey, what we can do is we can actually cheat. A large language model can tell the small model what is the right weight or what is the target at the time of training. And that means that a small language model, even with lesser number of parameters, can learn faster and provide better accuracy because it knows what the target is. This also has the annotation of, sometimes people call it the teacher and student model. So the teacher model is the large model. Because you have a large model, you can give some same examples and find out what should be the right value of W here for that example. And during the training, pass that as a soft target to a small model. And this way of distilling the knowledge from a large model to a small model is called distillation or teacher student model. And this is used almost in every SLM you have seen. So here are the three major techniques. One is quantization, pruning, and third is distillation, which allows you combined to take a 90 billion parameter model and convert it into a 1 billion parameter model. And at the time of inference, even reduce it to some 250 million parameter so that you can actually run it on your laptop or in your phones. That's the goal, right? Or a small GPU chip in cloud, like a T4, which is in a Colab available for free on Google. So you can do your research, you can actually build your projects, or you can even learn machine learning, right? So this is what is out there, and that's the goal for the session today. So I think I'm almost done. We'll do a few more things and then we can run to questions. So let me share my screen again. And I will just lay the land of. So this is the example where if you can see what they did is they are using pruning and distillation. This is what I took from Llama 3.2, the latest blog from Meta. And here what they did is they took pre-trained 70 billion parameter model and 8 billion parameter model. And with this logit data, which is the distillation, they took this soft target and then used them, and then they pruned this model and then use this data to train this small 1 billion parameter model. And here what they are doing is they're using their largest model, 405 billion, to generate synthetic data and using that to train this small model faster. So this is what I instructor tune small 1 billion to 3 billion parameter model in creation. First, you got the best weights, And then you use the synthetic data, which is already tuned using instruction tuning from 405 billion parameter, largest model that Llama has ever produced. You use that to train, and you make the cost of training or building these models like 100x lower by combining these techniques. And they also use quantization in their paper. Highly recommend you to read it. The landscape, this is the most growing field. If you go to Hugging Face, which is a repository where everybody stores their open source models, you can just filter on a small size, select the number of parameter. I filtered on 1 to 3 billion, and you can see just hundreds and hundreds of models released here, like Google Gamma is here. So you can just see all these models, and you can even try them. So this is a thriving ecosystem which you can build on top. How can you actually make this happen? There's a link to a lab. This lab is pretty cool. What it does is it actually takes, show you how can you actually take a model from what I just showed you, the Hugging Face library, and then convert it into TinyML, which is a library that Google provides. And using that, you can actually run this on your phones or on your laptops accelerated. So actually, I've done this. So this is the lab. And here I have actually hosted it on my, it was very simple 4 steps. So if you follow the lab, it's basically simple. You just take it, you copy this lab code, make a single line change, put the name. Once you convert it, and we have also put the model, converted model. So you can just download the model, make one line change that here is my model in the code, and then run this command. And if you run it, you can see this on your local host, and you can actually ask any questions, and it will get you responses. So that's pretty much the idea, or the lab, or the ideas I wanted to convey. It takes some time because, of course, it's a small language model running on my PC. But you can see, right, that it talks, it got all the ideas. I have a spelling error, and it got the idea that I'm also talking about other things like Edge AI by EDAI, and gave me exactly what I was looking for. So these are the power of small language models, which you saw in a emergent world of large language model. Actually, now this is running on my simple $1,000 laptop while I'm doing this session over video. So you can do the lab, highly recommended. And last thing, of course, I have a course that I teach. We go through all these concepts of neural networks. We do labs for product managers with templates, like how can you actually build an end-to-end PRD of how can you evaluate a large language model? How should you price a large language model? What are the trade-offs you need to make? So these are the templates or labs we do. And we also build an end-to-end product by hands-on learning. So I highly recommend you to join our next cohort. If you can't, I also do these Saturday community sessions, which should look like this session. And we are making them lightning sessions. So hopefully I will see you every Saturday, and we can have knowledge sharing and learning like we just had. That's all I had. I will stay back for 10-15 minutes for Q&A. And that concludes our session. Thank you again for joining. It's always good to see so many people so early on. Thanks, team. I can take any questions. Karan, maybe you want to, if there are questions on chat, I can take them now, or just raise your hand if you want to ask a question. Thank you. Thanks, Valesh. Thank Valens.
So Priya has asked, how is the SLM different from a local relational database?
How a small language model is different from a database. A database is a storage.
From a local
A
relation.
small language model is intelligence. So the small language models are trained, while a database is what you store values in it and you retrieve values. So whatever you store, you only get what you store. So it's very deterministic. While a small language model is a very interesting and exciting thing, because you store them, you show it a lot of things, but you store nothing, and it trains itself to solve particular problems. And once it has solved particular problems, then you can just ask, give it a problem, and it will solve it. and you'd never know how will it resolve it. So it's the most creative thing that we created, and I think the databases are the most boring thing we ever created. Anybody just ask if you want to raise
Priya,
your
I
hand,
think you
you
have
can
another
also raise
question.
your
You can
hand
ask
and
it.
we can have a discussion.
I guess thanks. First of all, an excellent session. I also like your whiteboarding that made it much more clearer. So I really appreciate that. I'm a designer and I'm getting into this. So I'm coming much more from the design and product side of things. Not that technical, but very curious. So I'm also in the course itself. Would you be covering the RAG part?
Yes. So we do three things in the course. We talk about first prompt engineering, and we help you build an first version of your idea just by prompts. Then we add RAG, which is retrieval augmented generation, where you can actually bring your documents, your things, and without writing a single line of code, you can actually make the LLM tailor to your needs. So we have a lab on that. And then we also show you how can you take a large language model and fine tune it, and people like Yating who are in this course can just say how great those labs are. But we not only talk about RAG, we build a lab and we help you add RAG and fine tuning in your own projects. So that's the goal. So
Brilliant.
hands-on
Thank you.
learning, concepts, and all. Priya.
Excellent. Thank you.
Gautam, you
But
can
good,
go next.
good to see always UX people, because I think the whole idea is that we all need to learn these tools and techniques, because that's what will be needed to build the next generation of products. So I'm very excited for people who are coming from different backgrounds, and that's the whole purpose of having the course. If you're very technical or if you have done AI products, actually you can learn all these things on your own. But if you've never built an AI product and you want to know like what goes in building it, like how to evaluate a model, what are the criterias that you should follow, how can you actually have trade-offs in within your team, all these plus hands-on lab is, I think, was needed for me to become better, and that's what I try to put in the course.
That's really encouraging. Thank you.
Thanks, Priya.
Gautam, you can go next if you want to.
Uh,
I saw your hand.
Hi, Mahesh. Yeah, hi, Mahesh. Great overview. Thanks a lot for that. I have one question. So I've been a product manager building, traditional ML models. So one thing that, typically, which is not done in that case is, traditional ML models, it's always said that data is pristine. And so a model can perform only as good as the data is. And therefore, let's say, you label it, handcraft data, and then you train a model, the model performs, the accuracy is higher. But then you use the model's output to train another model. Let's say the model's accuracy, the data was used to train the original model is at 98%, 99% accuracy. The model's accuracy would be around, say, 95%. And then the output of the model, or the data generated by a model, which will be used to train another model, if that is the case, then the third model, the second model that gets trained, has a much lower accuracy than 95%. Distillation kind of uses the same approach, where you've pre-trained a larger model that generates the data, and then that data is being used to train a smaller model. So will there be the biases or accuracy losses from the larger model that will be propagated to the smaller model? Is that something that we should be worried about?
Yeah, so a couple of things. You unboxed a lot of things. So let me just take you step by step and reach eventually this destination. So first is, what is the difference between older and new world? So if you did traditional predictive based machine learning and AI, the new world is that data, I think, is very important, but not to get started now. So Gen AI actually made it possible for, because these large companies or OpenAI or Google, what they have done is they have taken all the data and created a model which you can just by prompting tailor to your own needs. And this is the first time. It has never happened before 2022. Before that, exactly what you were saying, Gautam, that you needed a lot of data, and then without that data, I can't do anything. But once you bring the data, I can improve the accuracy. So that has changed, first of all. You can actually build a good MVP by just doing prompt engineering with a large language model. So that's number one. Number two is, how, okay, we are using these large language models to train these small language models. So if you look at like where they are training them. So they used to train it for instruction tuning, which is like how you follow instructions, not how you solve the core problem or how you think or what knowledge you have, but how you follow instructions, which is, I agree with you that 4 to 5% you will have a delta or even 10% delta, but it will have instruction tuning within like 1/100th of the cost. So that's what they're using it for synthetic data, also like instruction tuning learnings. And that's what they use the large model for. At least the Llama people use that way. So where you use it has an advantage because instruction tuning is a very expensive and hard process. And you can actually take some accuracy loss there because obviously what the loss is that you need to tell me twice. I may not be able to understand your instructions. Instructions is how you prompt them or how you talk to them. Like you ask a model, hey, what's the difference between edge AI and large language model? I will be 5% less than you. It will always be that. So you were right that there will always be this accuracy delta between the large and the small model. And there is a chances that if the large model has some biases or some problems, you are also passing it to the small language model. But overall, from customer experience perspective, all you are going to lose is that you will have to ask the question twice or thrice. And if that's okay, you can actually save 1000x in cost and have application build, which was impossible before to build with only large language model. So the capability or the cost or the advantage of doing this is much more than the loss you are doing in your process. So I think there's a business justification. If you just stick to technical terms, you are right that these will be behind and always behind the large language models. But the delta is like not more than 5 to 10%.
Got it. Got it. Thank you. That helps.
Thanks, Gautam.
Mirza, would you
It's
like to go
always good to
first?
see.
Yes, please. Thank you so much, Mahesh. I had a question on product discovery and ideation. Now, I'm working in a large financial services firm, and here we're just trying to set foot in AI, but we're not exactly sure what problems can this help us solve. So, on the strategy or the high-level discovery and ideation, phase, what do you recommend? How do we evaluate how AI can help? What problems can it solve, and things like that?
Yeah, this is a very good question. This is a perfect time for product managers to chime in because this is the first time we have more solutions and we are looking for problems. We have lived in a world for so long where we had so many problems. There's some sound from your audio. If you can mute it, I think it will help. Yeah, great. Changed my life. So I think that's a exciting time for product managers to live, but this is the most challenging time as well because everybody's asking you to spend money on Gen AI or AI, but you are basically your neck is on the line to make the investment correctly. So how I think about like where to find or what to find to build, and this is the only reason or one of the major reason why I switched from a TL or software engineer to product manager 4 years ago, because right now the cost of building things have gone 100x lower, but what to build is the most important thing, and that's what product managers are good at. So here are my 3 tips. One is first look at the processes that in your company that are redundant, repeated, and boring for people to do, and see if you can automate them and start with text. So that's number one. Number two, do a research in your area. So if you're working in financial, let's say, and let's say narrow it further, insurance, then see what are the startups or YC is a company, YC is a VC firm which funds a lot of startups, and they are funding only AI startups for last 2 years. See where these companies are innovating. So you can just get some ideas from that. And the third and most important part is see what is your top problems which you never looked at before, not even possible before. And now, this is the first time they are possible. So I was talking or listening to, I was talking to a few friends and also listened to a podcast by YC where they said this $1 billion opportunity in SaaS is to build vertical solutions. And they talked to this case text CEO John, I believe, and he was explaining how it was impossible for him to do search across legal document and find similar cases before LLMs arrived. And it was so hard. They tried to solve that problem for 10 years and kind of made progress, but never really found that use case or found a solution for these top problems. Because if you're a lawyer and if you're preparing for a case, or you're looking in thousands and thousands of documents to see if this company has ever done fraud, it's almost impossible to build that search and through search engine tech we had done. But now, as soon as LLMs came, they threw all their company on it. They solved that upper use case, which was not possible before. And within 4 months, they sold for $650 million to Thomson and Reuters because Thomson and Reuters had exactly same and they saw the threat, or they wanted to get into Gen AI. So these are the 3 tips. First, look at all the boring scenarios that earlier were hard to automate them away. Take the ideas from startups because startups are actually have done the discovery part, and YC has ensured when they funded them. So there is a cheat sheet there. And third, of course, is look at the top problems in your org or the most expensive things you are doing and see what percentage or how can you build an assist scenario for these people, and then narrow on one use case and one person and starts from there. And if that doesn't work, narrow on second and third, and hopefully you will find a use case. Once you have a use case, you work backward from there. And if you come to our course, obviously I will keep selling the course. But the idea is that you can actually learn all these things. We have few use cases and people have solved some finance exciting use cases, especially around due diligence and all. And that's what we do. We actually look at what the problem should be and how you actually build backward and use this tech. And then the goal is that you can see the limitation of this tech. I think people are super excited about the tech, but it has serious limitations and serious shortcomings that you as a product manager should know. And you should have frameworks on how you can bring along your customers, your leadership, and your engineering team while knowing the limitations. So that I think we do a good job at through our templates and lessons week after week. I know I made it a pitch.
Thank you so much.
I think
No, thank you so much.
I think
This
you
was
actually
really
invited a pitch.
This was really amazing to know. Just on that, can you just give me 3 important concepts that learning those concepts will help, in discovery and ideation?
Yeah, so I think discovery and ideation, the number one idea that you should follow is who you are solving for, which is like who is your audience. So that's number one. And second one you should look at is what they are doing and what's not possible for them, or what in the strategy that has not worked in past in that area or that problem area or that solution space. And third is what's new that can actually change it. And then keep applying this to your top personas, and hopefully you will reach one mix where you can apply something new or groundbreaking. This is a framework which is for new and groundbreaking technologies. I think that was your question, not just what you can learn from any blog out there. This is how I think.
Thank you so much. Yeah, thank you so much.
No problem. I can take one more question. I really need to run after that. But Karan is here. He will put my LinkedIn. If you have more, reach out to Karan. Karan can take some questions or help you guide further, or happy to take things over LinkedIn. Let's take the last question.
So Sebastian had a question. Are SLM able to tailor responses for an expected JSON schema as output?
Yeah, so everything actually, this is a very good question. So you have a use case, and the use case is that you will give it an input, but the output needed a format like JSON or XML or maybe key value pair format, because downstream you want to use it in your apps. Some code is written, and JSON is a very good example. And if you can do it with the large language models, you can do it here. So that's the whole idea of building SLMs, that you can actually do and JSON is like a solved problem these days. It's coming as a button these days or a single prompt. So if you have that, you can actually do it with SLM. So the answer is yes, but you need to train a little bit on accuracy. And train means you have to do prompt engineering. No need to write code or anything, but it should work. And if it doesn't, we'll figure it out together. Let us know. Start with our lab. With that, thanks again for joining me that early. It is always fun to meet a lot of people and share whatever I know. So thank you again. And hopefully I will see you on our Saturday sessions. Till then, bye.